I'm Colby with Eco Drip Irrigation, and I'm going to present two different soil moisture sensors here. They're both a time domain sensor, so they're reading volumetric water content. And if you might want to stand a little bit closer. For this demonstration, we just put in 3 different sensors at the 1 foot, 2 foot, and 3 foot level. The ones on your left will be they're a Campbell 655 sensor, and they're a TDT sensor. And the sensors on the right are an Acclima 315, and they are a true TDR sensor. So they're using a waveform to measure the speed between the 2 prongs to give us a volumetric water content of that soil. So typically when we do an install, we don't have a hole this big. This is just for a demo, and Lance can sit down in the middle of the hole. But we'll have a lot smaller hole, and then we'll measure off of the top of the soil, and we'll poke into the ground about halfway down that rod, because we're using the rod lengths are 12 centimeters on the probes. And then you'll pull it out, and then we'll go ahead and slide the sensor in, which we don't have an extra Campbell sensor, but he'll show you the Acclima one later. We'll slide it in, and then we'll tie all of the wires together, and they can come back into one single wire lead that will go to our census, or our RMU unit. So real simple, just slides into the embankment, and we're going into fresh, undisturbed soil, so we don't need any type of slurry or anything. Okay, Lance, go ahead and show it. Now we have the Acclima probe, and it's really critical that those prongs stay parallel when they go in, so there's always some type of guide. You don't ever want to stick them in by themselves, because then they can either go apart or come together, and they can disrupt the readings. So just simply slides in like that. And then these are all smart sensors that are all addressed, so they come back into one wire. So this is one thing that makes these sensors very unique, is we can take those Campbell sensors, we can run it underground in a conduit, and we can run our actual telemetry unit out to the edge of the field and have it completely out of the way. And then these will be permanently buried, a permanent install, so they'll last for years underground. We don't have to come back in and install them every year. This telemetry box that we make can actually accompany 10 different sensors with it. So you could have, theoretically, if you had 3 different depths, you could go to 3 different locations in the field and still use that same telemetry unit, as long as you stayed within the range of that wire run. The Acclima sensors don't go quite as far. I think they publish 400 feet, but still, if you strategically place it in the field, you can get a lot of different soil types or variation across that field when you're getting your measurements. That's pretty much it. We'll typically put that conduit in 18 to 24 inches, because we'll rip it in with a ripper. If there was a reason to go deeper, we would trench it in, but anytime that we can rip it in, it goes quicker. I apologize if you can't see this, but we basically take 3 different readings from these sensors. We'll take a soil temperature reading, and here you can see this is one that's up by Hastings, Nebraska, that just shows how the temperature's been changing. So our top layer is actually now warmer than our lower layers. It has flipped, they've all crossed. And the website actually has a bunch of different widgets, so you can pull them in to different views. If you like a graph view, you can have a graph view to see how that soil moves, or you can have a gauge view and actually show the actual readings as they are when you pull it up. The other thing that we're reading is bulk EC. So if you have very salty water or a saline soil, you can see as your irrigations go how you're moving those salts up and down. If you don't have a salty soil and you're applying nitrogen through the system, a lot of times you can actually see that nitrogen movement in there, and if you're going down to the lower levels. This one, he hasn't been doing any fertilizing or anything, so it's not really showing much on the graph. And then the big one is the volumetric water content. So this is percent water in your soil. So this is a direct measurement that you can take. You take your soil type and your field capacity and your wilting point of that soil, and it'll be unique for every soil and every field, but you'll find those values, and then you can manage it, early in the season on your top layers and later in your season on your bottom layers, and really fine tune where that volumetric water content is. A little bit on EcoDrip. We have a location up in Hastings, Nebraska. That's where Lance and I are from. And then we have a location in Stratford, Texas. So that's where we do all of our service work out of. And then that's pretty much everything for my slideshow. I'm going to add one more thing that we've been doing. Our company, as EcoDrip, actually does subsurface drip irrigation. So most of this ties to subsurface drip irrigation, but it can be used for any type of irrigation. But one thing we're doing is we're actually tying this into this other controller that's sitting here, and that's our irrigation controller. And we're getting that set up where we have trigger points, so we actually can trigger different irrigations with that drip system. And those triggers can come automatically, or they can come as warnings, just to make it a much more efficient system. Anything else I'm missing, Lance, you can think of? Oh, yeah, the placement of moisture probes on a drip irrigation system is very critical. So if anybody specifically wants to talk about that later, stick around and come talk to me, because you can get very poor readings if you don't place those in the right area. I guess the last thing I didn't really talk about, when we fill this hole back in, and again, the hole's not going to be this big, it's very critical to get that hole filled in and back to exact grade of what it was before, so you don't have a little indention there where water can sit and skew your readings from what the rest of the field is. But from there, I guess I'll take any questions.
Does that soil equalize with regard to moisture content? Do you water pack them?
We don't water pack them. Typically, we'll put them in layers and pack it down to get it as best we can to the same compaction that it was before. You do have some transition between it, but where the probes are actually reading, it is in undisturbed soil to the side. So the critical thing is to get the compaction and then making sure that we don't have any settling there or a mound there that would skew any rainfall or irrigation events from that. Any other questions? If not, I think that's all I got. I can't really, if anybody's interested to stick around afterwards, they can come up and I can show you what the actual graphs are and some different fields and what they mean. These sensors have only been in here for 24 hours, so I don't really have very much readings that I can show you directly from these sensors. But if not, that's all I got. Thank you.